In this demo, we will show how to calibrate the Olympus Magna-Mike 8600 using the 0.045-inch or 1.14 millimeter diameter 86TW1 wire target with the 86PR-1 straight probe and 86PRS1 probe stand. We will then insert the wire into the cooling hole of a turbine blade to measure the material thickness of the blade to the cooling hole. The thicker side is about 0.092 inches or 2.34 millimeters. The thinner side is about 0.033 inches or 0.84 millimeters. We will be using the 86ACC-W- kit, which includes the target wires, as well as wire on fixtures and reference standards designed to be used with the wire targets. We will be using the Magna-Mike in an area free from interference from magnetic materials. The first step would be to connect the probe and probe cable to the instrument and then turn the instrument on. It is important to let the instrument warm up for at least 5 minutes before using it so the probe can reach a steady-state temperature condition. The Magna-Mike 8600 can auto-detect the different size target balls, but it cannot auto-detect the wire or disc targets. Therefore, we will need to tell the instrument what target we are going to use. To do this, press the Setup key. Then, with Measurement highlighted, press the right arrow so Target Select is highlighted, then press the Enter key. Press the left arrow until 0.045 wire is selected. Then press the Measure key. On the main measurement screen, the instrument will now display the target being used. Before beginning to calibrate, it is good practice to make sure the wear cap on the probe is screwed on securely and the instrument is in an environment with ambient temperature that is free of magnetic interference. The instrument should be in the location that it will be used in on a regular basis. We can now calibrate. To initiate the calibration process, press the Cal key. The first step of calibration is to perform a ball-off. To do this, make sure the wire is removed from the probe tip, then press the Cal key. Once the instrument is done processing, the next step is to perform a ball-on. To do this, take the 86 CAL-TW1 alignment fixture out of the calibration kit. Next, loosen the top cap on the fixture. Loosen it enough to allow for the wire target to be slid into the slot on the side of the fixture, then insert the wire. Once the wire is inserted, screw the top cap down so it is secure and the wire is aligned properly. The top of the fixture includes a hole, so the user can verify the wire is centered. Do not screw the cap down too much as the wire can be damaged. Then, place the fixtured wire on the probe and gently pull down on the sides of the fixture to ensure the wire is in contact with the probe tip, then press the Cal key. After processing, the gauge will display a 0 value. We can now remove the wire and fixture. The gauge will then ask for a thin shim and call out an approximate thickness. The thin shim called out for the wire target being used is 0.0400, or if you are using metric units, it would be 1.016. The English units of approximate thickness being called out for the thin shim corresponds to a part number in the calibration kit. So the next step is to find the 86WCAL-040 reference standard. The reference standards include a shim made either of brass or aluminum that is a particular thickness. The actual thickness of the shim is printed on the reference standard in English and metric units. It is very important to enter the actual thickness of the shim and not the approximate thickness that is being called out by the instrument. In this case, the thickness printed is 0.0404 inches or 1.026 millimeters. We will then unscrew the top cap enough to allow for the wire to be slid through the slot on the side of the fixture. Make sure that the wire is on top of the shim so that when it is placed on the probe, the shim is between the wire and the probe tip. Then, screw the top cap down enough so it is secure and the wire is aligned properly. Then place the wire and calibration fixture on the probe and gently pull down on the sides of the fixture to make sure the probe tip is in contact with the shim. The instrument will start displaying a thickness value. Once the reading is steady, press the cal key. Then use the arrow keys to input the precise thickness of the shim, which in this case is 0.0404 inches or 1.026 millimeters. Then press the cal key. We can then remove the wire and calibration standard. The gauge will then ask for a thick shim and call out an approximate thickness value for the thick shim to use. The thick shim called out for the wire target being used is 0.1600, or if you are using metric units, it would be 4.064. The next step is to take out the 86W-CAL-160 reference standard. The top cap can then be unscrewed enough to allow for the wire to be slid through the slot on the side of the fixture. Once again, make sure that the wire is on top of the shim so that when it is placed on the probe, the shim is between the wire and the probe tip. Then, screw the top cap down enough so it is secure and the wire is aligned properly. Then, place the wire and calibration fixture on the probe and gently pull down on the sides of the fixture to make sure the probe tip is in contact with the shim. The instrument will start displaying a thickness value. Once the reading is steady, press the cal key. Then use the arrow keys to input the precise thickness of the shim, which in this case is 0.1600 inches or 4.064 millimeters. Then press the cal key. The gauge will then ask if we want to add additional calibration points. If we choose no, the calibration process is over and we have completed a basic calibration. The recommendation is to always add additional calibration points since it improves measurement accuracy. Therefore, we will press the left arrow key to highlight yes, and then press the Enter key. The gauge now shows the thin and thick calibration points we have already entered, and it is asking for the next calibration point. At this point, we can add in the other reference standards from the calibration kit that we have not yet entered. We can remove the thick shim fixture. We can then take out the 86W-CAL-010 reference standard. Then we will loosen the cap and insert the wire into the slot on the side of the fixture and then screw down the cap until it is secure. We will then place it on the probe and pull down gently on the calibration fixture. The instrument will start displaying a measurement. Once the reading on screen is steady, we will press the cal key. Once the instrument is finished processing, we will use the arrow keys to change the value to the exact thickness of the shim, which in this case is 0.0101 inches or 0.257 millimeters. We will then press the cal key, which will add the thickness to the list of calibration points. We can then repeat this process for the other calibration standards until they are all added to the list of calibration points. Once they have all been entered, we can press the Measure key. We have now completed a full multi-point calibration. It is good practice to check a few of the reference standards after the calibration has been completed to make sure they are measuring within specification. If they are not, you can try removing the target from the probe tip and then pressing the Q-Cal key. We will check the 10,000ths of an inch shim to make sure it is measuring within specifications, which it is. Then we will check the 80,000ths of an inch shim to make sure it is measuring within specifications, which it is. So once we have confirmed the reference standards are measuring within specifications, we are now ready to make measurements on the actual part. The true thickness will be when the target is directly over the center of the probe tip, which also corresponds to the minimum thickness measurement. The gauge will read a thicker measurement when the part is misaligned. For this reason, it is recommended to enable the minimum capture feature. To do this, we will press the minimum-maximum key and then enable minimum to on by pressing the right arrow. We can then press the Measure key to return to the main measurement screen. We can now insert the wire target into the cooling hole of the turbine blade and place the thicker side of the turbine blade on the probe tip so the gauge is measuring the distance from the probe tip to the wire target and displaying the thickness of the turbine blade. At any time, we can press the Measure key to reset the captured readings. We can scan along the length of the part and also rotate the part. The minimum thickness will be updated as we scan. We can press the Enter key to freeze the measurements on screen so we can rotate the part to measure the thinner side without capturing false readings. Once the thinner side is in contact with the probe tip, we can press the Enter key to unfreeze the measurements and the minimum thickness will be updated. These measurements can be saved to the internal data logger of the instrument, or they can be sent directly to a spreadsheet. Now, if another target is used and the customer wants to recall the setup for the wire target we just used, they can press the File key and then keep pressing the down arrow until the Cal Recall is highlighted. Then they can press Enter. Here we see a list of calibrated targets. The user can highlight the 0.045 wire target and then press Enter, and then Enter again on recall. Whenever you recall a calibration file, it is always recommended to remove the target from the probe tip and perform a QCal by pressing the QCal key. It is also good practice to then check a few reference standards to make sure the instrument is reading within specification and a new full multi-point calibration is not needed.